Hello and welcome to Mike Academy. In today's video, we are going to be looking at numerical differentiation and numerical analysis using the Newton's forward formula. And we are going to be solving two examples in this video to explain the Newton's forward formula. So let's consider the first example. It says compute the first, second, and third derivative when x is equal to 1.5 given this table. So in the first video, I explained the difference between the forward table, the central table, and the backward table when given a particular value of x. Now, if you take a look at this table, excluding this table that contains x and y, let's consider now the table of real values. We simply have for x 1, 2, 3, 4, 5, 6 tables here containing real values, right? So which means these 6 tables can be broken down into 3, can be divided into 3. So we'll have the first 3, okay, then you have the next 3. So the first 3 could be categorized as a forward table, the last 3 could be categorized as a backward table, then any value in this case now, any value between 2.5 and 3.0 is now considered the central table. So this simply means if a value falls between 1.5 and 2.5, we are going to be using the Newton's forward formula to actually solve that value, that problem. Again, if a value of x falls between 3.0 to 4.0, it means we are going to be using the Newton's backward formula to solve to approximate that derivative. But any value now that falls between 2.5 and 3.0 is said to occur at the center of the table. In that case, we'll simply use the Newton's central difference formula to solve or approximate that derivative. So I explained all of this in the first video, and I will leave the link of that video in the description of this video so you can watch that video for proper understanding of all of these methods and approaches. Okay, so we are now to approximate when x is equal to 1.5, and you can see, like I said, this is the forward table and this is the backward table. So you see now that 1.5 lies at the beginning of the table, so which means we are simply going to be using the forward Newton's forward formula, which is the essence of this particular video. So for the first derivative, the formula simply states dy all over the x is equal to f of x plus h minus f of x all over h. Where I explained in the first video that h simply means a step size or an interval, which simply means the successive differences in the values of x. Sorry. Okay, so which means h can be found simply either as x2 minus x1, or it can also be found as x3 minus x2 or x4 minus x3 and so on. But whichever it is, the value of h must remain the same, okay, for you to be able to accurately use this method. The value of h or the interval must be constant, it must remain the same. So let's try this and see now. H is going to be equal to x2 from the table is 2.0. So you have 2.0 minus x1 is 1.5 minus 1.5. So this simply implies that h is going to be equal to 0.5. So our interval is 0.5. In the same vein, if you compute x3 minus x2, you have 2.5 minus 2.0. That still gives you 0.5. So the interval is constant if you must be able to use this formula accurately. All right, now that we found the value of h, the next thing to find from the question, from the formula, is f of x plus h. So we simply find f of x plus h. Now this is equal to fx. Here simply means the point of interest, what we are being told to approximate the derivative about. And from the question, when x is 1.5, so we have to find the first derivative when x is 1.5. So x is simply 1.5. So we put it down, 1.5 plus 0.5, which is h. So plus 0.5. This is going to give us f of 1.5 plus 0.5 simply gives us 2.0, right? So you now look at the table. What is the value of f of x when x is 2.0? When x is 2.0, f of x is simply what? 7.0. So this simply means f of 2.0 equals 7.0. So we'll find the value of f of x plus h. The next is to find f of x. So we find f of x. This simply means f of x is, remember again, the point of interest, which is 1.5. So we find the value of f of x when x is 1.5. When x is 1.5, f of x gives us here 3.375. So f of 1.5 equals 3.375, and you have this. So you simply compute all of this into the formula. Now the formula becomes, you have f of x plus h, and f of x plus h gave us 7.0. So that becomes 7.0, or 7 minus f of x. F of x itself gave us here 3.375. So 7 minus 3.375 divided by h, and h is the interval from the question we obtained, 0.5. So divide by 0.5. So this is going to be equal to, let us find 7 minus 3.375 divides 0.5. So 7 minus 3.375 simply gives us 3.625. Divide by 0.5. This will give our first derivative to be dy all over the x equals 7.25. So this becomes the first derivative approximation for that given question when x is equal to 1.5. Now the next is to find the second derivative. For the second derivative, in the first video I gave out this formula: the squared y all over the x squared is going to be equal to, so we said, f of x plus 2h minus f of x plus h, minus 2f of x plus h plus f of x all over h squared. So once again, we need to find f of x plus 2h. We already know what f of x plus h is. We know what f of x is. Let's now just look for f of x plus 2h. Okay, so f of x plus 2h simply means f, remember x is 1.5, the point of interest, now plus 2 times the interval. Interval is 0.5 times 0.5. So this simply gives us f of 1.5 plus 2 times 0.5 simply gives us 1. So this simply implies that f of x plus 2h is actually f of 1.5 plus 1 is 2.5. So that's f of 2.5. So this will be equal to, so from the table, when x is 2.5, f of x itself is 13.625, right? So that means f of 2.5 equals 13.625. Okay, so let's couple everything now into the formula. We can now find that d squared y all over the x squared is equal to, it says f of x plus 2h, and f of x plus 2h gave us 13.625. So we have 13.625 minus, this is 2 times f of x plus h, and once again f of x plus h gave us 7, so you can see it here, f of x plus h, that gave us 7. Okay, so minus 2 times 7 plus f of x, and f of x itself gave us 3.375. So plus 3.375 divide by h squared, which is 0.5 all squared. Okay, so this is equal to, we have 13.625, okay, minus 2 times 7 is 14, plus 3.375 divided by 0.5 squared gives us 0.25. So d squared y all over the x squared is going to be equal to, so let's compute everything at the numerator, 13.625 minus 14 plus 3.375. So everything at the numerator simply gives us 3 upon evaluation divides 0.25. Okay, so let's obtain this ratio. That simply gives us 12. So this implies that the double derivative, the squared y all over the x squared, is equal to 12 when x is 1.5. And finally, for this question, we compute the third derivative. Okay, so for the third derivative, the formula is the cube y all over the x cube, that is equal to f of x plus 3h minus f minus 3 f of x plus 2h plus 3 f of x plus h minus f of x divided by h cube. Okay, so that means all we are looking for now is simply f of x plus 3h. That's all we are looking for, because we have invariably every other parameters solved out there. So we find f of x plus 3h. So f of x plus 3h is equal to f of x is 1.5 plus, now this becomes 3 times 0.5. So this is going to be equal to f of, so let's compute 1.5 plus 3 times 0.5. So 3 times 0.5 is 1.5 plus 1.5, that gives us f of 3. So from the table, that means that f of x plus 3h, which is equal to f of 3, is going to be equal to, so f of 3, when x is 3, what is the value of f of x? The value here is 24.0. So which means f of 3 equals 24. Okay. All right. So you have this now. You can simply plug into the equation. So the cube y all over the x cube is equal to f of x plus 3h is 24 minus 3 times f of x plus 2h, and f of x plus 2h gave us 13.625. 13.625 plus 3 times f of x plus h. F of x plus h itself give us 7. So 3 times 7 minus f of x, and f of x give us 3.375 minus 3.375 divides by 0.5 to the power of 3. So just to save time and space, I will evaluate everything at the numerator altogether. So do well to punch along with me to avoid calculation errors. Okay. So everything at numerator upon evaluation simply gives us 0.75. Okay, divided by, let's obtain 0.5 to the power of 3. That gives us 0.125. Okay, so this simply implies that the third derivative approximation, the cube y all over the x cube, is going to be equal to, so let's obtain 0.75 divided 0.125. That simply gives us 6. So the third derivative when x is equal to 1.5 is simply 6 for that given question. Okay, so let's dive straight into the second question. I'm sure you don't want to miss out on that question. So watch through the video to the end, and at the end of the video, I'm going to be leaving you guys with a classwork, and I expect you to do it, play around with it, and maybe send me your results in the comment section or on my WhatsApp displaying right on the screen. All right. So let's consider the second question. It says compute the second and third derivative when x is equal to 0.98. Okay, so once again, in this case, this table that contains values is categorized into five different places. So table with values are 1, 2, 3, 4, and 5. So which means the first two will represent our forward table, the last two represent the backward table, and any value that falls at the center here, we simply employ the central difference method to solve. So for the purpose of this video, we're actually using the Newton's forward formula approach to solve. So this value to be differentiated is when x is 0.98, and 0.98 lies at the forward beginning of the table. So this is the forward table, right? So 0.98 lies at the forward of the table, so which means we are going to be using the Newton's forward formula to solving this derivative. So we have to do the compute the second derivative and the third derivative. Okay, so the formulas are already here for the second derivative. So all we need to do is find f of x plus 2h, find f of x plus h, and find f of x, and we are good to go. So let's start with f of x. So we find f of x, which means f when x is equal to, x is the point of interest, that's 0.98. Okay, so you have 0.98. So what is the value of f of x when x is 0.98. So this is 0.98. So f of x there is simply 0.7739. So when x is 0.98, f of x is 0.7739, and you have this. Mind you, we need to find the interval. So interval h is actually x2 minus x1, and that's going to be equal to x2 is 0.98 minus x1 is 0.96. So you have 0.98 minus 0.96. That gives us about 0.02. So 0.02 becomes our interval. Okay, so we have f of x. Next, let's find f of x plus h. So f of x plus h is equal to x is the point of interest, which is 0.98. H now is the interval 0.02. So we'll have plus 0.02. So this is actually f of 0.98 plus 0.02 gives us 1.0. So this is going to be equal to, what is the value of f of x when x is 1.0? So this is 1.0. This is f of x. The value there is simply 0.7651. Okay, so you have 0.7651. Okay, next from the formula is f of x plus 2h. So we find f of x plus 2h. This is going to be f of x itself is 0.98 plus 2h is simply 2 times 0.02. So this is actually f of 0.98 plus 2 times 0.02 is 0.04. So which means f of x plus 2h is going to be equal to 0.98 plus 0.04 gives us 1.02. So we find f of 1.02. What is the value of f of x when x is 1.02? The value from the table is simply 0.7563. So you have 0.7563 when x is 1.02. Okay, so we have everything all set and done. Let's now plug into the formula. So the squared y all over the x squared is going to now be equal to f of x plus 2h. That value simply gave us 0.7563. Okay, so you have 0.7563 minus 2 times f of x plus h, and f of x plus h simply gave us 0.7651. So 2 times 0.7651 plus f of x, and f of x gave us here 0.7739. So you have plus 0.7739 divides by h squared. H is 0.02 all squared, right? So this is going to be equal to, so for the sake of time, I'm going to solve or evaluate everything at the numerator all together. So do well to, point along with me to avoid calculation errors. Okay. So everything at the numerator simply give us 0 after evaluation. Then for 0.02 squared, that simply gives us 0.0004. Okay, so of course, if you divide that, whichever it is, you simply have the squared y all over the x squared to be equal to 0. So the second derivative approximation when x is 0.98 is actually 0. So we try for the third derivative. So if you look at the formula, the only thing we need to find for the third derivative now is f of x plus 3h. Every other thing in the formula, we've already gotten it. So let's find f of x plus 3h. So f of x plus 3h is going to be equal to f of x is 0.98, okay, plus 3 times 0.02. So this will be equal to f of 0.98 plus 3 times 0.02 is 0.06. So we have plus 0.06. So this simply implies that f of x plus 3h is equal to f of, so let's find 0.98 plus 0.06, and that simply gives us 1.04. So we'll have f of 1.04. So from the table, when x is 1.04, f of x is equal to 0.7473. So f of x equals 0.7473 when x is 1.04. So we simply plug into this formula. So the cube y all over the x cube is now equal to f of x plus 3h, which is 0.7473 minus 3 into f of x plus 2h, and that gives us f of x plus 2h is simply 0.7563 plus 3f of x plus h. F of x plus h simply gives us 0.7651, okay, minus f of x itself, that simply gives us 0.7739. The whole of this divides by h cube, 0.02 all to the power of 3. Okay, so just like in the previous, I'm going to point everything all along. So do well to point along with me to avoid calculation error. So let's do that to save time. Okay, so the cube y over the x cube is now going to be, so everything at the numerator simply give us negative 0.0002 divides by, let's find 0.02 to the power of 3. So 0.02 to the power of 3 simply gives us 0.000008. Okay, so let's find 0.0002 divides by that answer. Divides 0.000008. That simply gives us 25. That's equal to 25. So the third derivative approximation when x is equal to 0.98 is actually 25. All right, guys, so that's how to employ the Newton's forward formula to solve numerical differentiation in numerical analysis. All right, so I promised in the beginning of the video that I was going to be leaving you guys with an assignment. So if you watch to this point of the video, then congratulations to you, you have the assignment. So I'm going to be stating down the assignment now. So you lay your hands, play around with it based on what we've learned, and then you can relate back to me via the comment section or via my WhatsApp number displaying right on the screen. Okay. All right, guys, so you can play around with this question, lay your hands on it, and give me your answers in the comment section or on my WhatsApp, and tell me what you actually noticed in this set of sort of arrangements. I hope to hear from you. Till I see you in the next video, stay blessed. Cheers.